Hey guys, I briefly want to cover scalars and vectors. You might already be familiar with these terms, but I'm going to tell you how we use them in physics. So in physics, a scalar quantity is any number, any physical quantity that has a unit, like, excuse me, time. So I can have 20 seconds, or I can have 10 pounds, or I can have 2 kilograms. Those are common scalar quantities. A vector is something similar in that it also has a number and a unit, like, let's say, 2 feet. But it also has a direction. So I'm going to have 2 feet north. Or I'm going to have 360 degrees clockwise. Or I'm going to have 50 miles per hour southeast. These are vector quantities. So it has both a size and a direction. So the first part is called magnitude. So it can be positive or negative. Sorry. It can be positive or 0. It can't be negative. So vectors are never negative. So I can have 2 feet north and 2 feet south, and they're opposites, but they're not negative. If I move 2 feet north and then I move 2 feet south, I end up at 0 because I can subtract them, but the two aren't negative. So common vectors that we'll be using in class will be displacement, and this tells us our change in position. So it doesn't matter where we are on a coordinate grid. We could be at the origin, and I can move 2 feet north. My displacement would be 2 feet north. However, if I'm at 3 feet west, or this would be east, 3 feet east, and then I move 2 feet north, start from 1, go up to 3, I've still moved 2 feet north, even though my coordinate system has changed. So displacement tells us a change in position and does not depend on origin. On the origin. Excuse my spelling. You'll get used to this throughout the year. I also want to take note of this nifty little symbol that I used here, the delta. Go to another page. So this will be the most commonly used symbol that you'll probably see in physics. Means change. Taken any upper level math classes, you already know this. So if I have a displacement, if I have a position, so that means my starting position, R1 is equal to 0, and R2 is equal to 2, I'm going to say that my change in position is equal to 2 feet. How did I get that? Because change in R, or position, is always going to be synonymous with my final position minus my initial position. Always, 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 when you're talking about vectors, it's final minus your initial. Okay, that's the end for this video. Thanks. Hey guys, bringing you back to our particle model of our basketball. So notice that I've added a couple things. I've added some definitive coordinates now. So now we can figure out the displacement of our ball. We can also figure out the time interval. And that'll lead us to figure out our last project for the night, velocity. So I want to know how far how much position was displaced by the basketball given the time frame. So change in position in the y direction, so I'm going to specifically talk about the y direction, is equal to my final y minus my initial y. Pretty easy. 2.5 meters minus 2 meters. So the total displacement was equal to 0.5 meters up. Increase the total of 0.5 meters. Notice that I completely ignored the fact that it went to 3 meters. It wasn't important to the problem because I only looked at final and the initial. Okay, now I'm going to look at horizontal displacement. So again, it's final minus initial. So I have 6 meters minus 0 meters. I'm going to find that it moved 6 meters to the right. Now I can use trig, which is something you need to be heavily familiar with when you're in this class. I can use trig to figure out the total displacement. So I want to find my delta R. Well, go back to my diagram. This is why diagrams are so important. This is my R. That's my displacement vector that I'm actually looking for. Here's my change in Y. Here's my change in X. Look at that. Right triangle. So now I can do r squared equals x squared plus y squared. And that'll give me my change in r. So, really quick, 36 plus 0.25 gives me 36.25, probably something like 6.1, 6.2. Okay. So now that that is out of the way, I can look at my time interval. So time interval can be done in a similar fashion. Okay, I want my delta t. Well, it's another delta, so it's just t final minus t initial. Take a look at our original problem. Started at 0 seconds. We ended at 3 seconds. 3 seconds minus 1 second. Oh, 0 seconds. That's when I started. Just checking to make sure you're paying attention. Gives me 3 seconds. Easy enough. Okay. Going on to the next step. So, when we started our problem for the basketball, I said that I wanted to know what the average speed was, or my average velocity. So here's another vector for you. So vector velocity, scalar, speed. I want to know what my average velocity is. So in order to do that, I need to take displacement, take my r, and I want to take time interval. And that's going to tell me my average speed. So for this problem, 6.1 divided by 3 always include your units. I'm not going to be able to stress this enough. Always include your units. 6.1, 3 seconds, gives me about 2 seconds. .03 for those of you keeping score at home. And that would be up and to the right. Okay, so why are speed and velocity so different? Well, speed is distance traveled. Over time. So I can travel a mile in about 9 minutes. But let's say I run around a track. So I have displacement over time. Well, if I run around a track, I'm going to start and stop at the same exact point. start, and end. What was my displacement? Well, remember, displacement is change in R. So final minus your initial. Well, if I started here, so if I started at 0, and I ended at 0, then my displacement is going to be 0. Took me some time. But my velocity ultimately is 0 for the entire duration. This is why velocity and speed are two completely different quantities. Okay, this is going to conclude the first night of videos. Thanks for watching, guys.